What I want to present you today is the methodology that we use to basically help you to improve your QA. That goes through collaborative innovation, as Olivier just mentioned, and also through a very specific methodology that I want to present you today. This methodology is based on 4 steps. First, it's about acquiring statistics on what are the current practices that PT sites are doing today. Then, it's about analyzing what is those current practices in terms of frequencies, in terms of devices, in terms of tolerance, etc. It's also about involving clinical partners as soon as the early stage of the project is starting. And then it's about releasing the product in the fastest way as possible. So at the end of this presentation, I will show you that we implemented a solution which allows you to reduce significantly your machine QA. And also using the data that you're collecting every day in a smart way about trend analysis, about benchmarking your site versus other PT sites. So first, we start looking at all of the current practice that were done on the PT site. We analyzed a ton of data, looking at the frequencies, looking at the tests, at the tolerances, at the devices that were used. Once we build that table, we start looking at it under different angles. First, we look in terms of duration and frequencies of those QA tests. We decided to focus on PBS, not only because it's extremely important today, but also because we noticed that many customers were struggling the most for their PBS QA. So some analysis we made showed us that for the daily QA, we were between, for instance, 20 minutes and an hour. For the monthly QA, between 2 hours to 6 hours. Yearly QA, 1 day to 3 days. So what's interesting is to look over a full year, how much time is spent today on quality insurance. So if you take day 1, January 1st, you're going to do 1 daily QA, 1 monthly QA, and 1 yearly QA. On day 2, you're going to do a daily QA again a daily QA. You're going to do that 20 times. February 1st, you're going to do another monthly QA, and this keeps going for a year. This might seem a bit long, but it's good to realize that QA is very time-consuming on a PT site. So our objective was to reduce that time, and the first thing we noticed is that daily QA is really where the biggest time was invested today. So we decided to focus first on PBS daily QA by trying to reduce by 3 the amount of time that is spent on daily QA. So that's our objective number 1, reduce PBS daily QA by 20 minutes a day, which is about 1 more patient per day. Okay, then we look at all of this data on another angle, on the device angle. What was used today? So today we have what we call the IBA zoo. You have, for instance, very specific device, such as the Zebra, which is great at measuring the energy. We have a Lynx, which is good to measure spot properties. We have matrices, which is a great patient QA device, but can also be used for machine QA. Then we have parallel chambers and so on. The thing is that none of these devices is measuring everything. And if you look, for instance, at some of them, you cannot, with a Zebra, measure the spot properties. That's just impossible. In some cases, you can do some measurement, but it's always by using some jigs and not always the device as they are supposed to be used. So a summary of this is that we noticed there were basically 2 schools of thought today. Some people using basically 1 device after the other to measure very accurately their parameters. So they will go from a Zebra to a Lynx to a parallel chamber. And then there is another school of thought, which is about using a device such as a matrix, for instance. What we looked at is that if we want to reach the accuracy that PBS is required, which is basically lower than 1 millimeter, we wanted to use a high-resolution device. Matrix is a great device, but it's got a resolution of 32 by 32. So just to give you an example, if this projector over there had a resolution of 32 by 32, my presentation will look like this. So as you can see, we are missing a lot of information. Those sweat cross who are the same, they all look different now. So hopefully that's not the case today. So the idea is really to have you not having to decide between quality and time. So our objective number 2 was to bring a device that was able to measure everything with a high level of quality. So as a summary, objective number 1, reduce the time it takes. Number 2, maintaining not only but actually also improving quality. And it was also about innovative collaboration, get the customer in the loop right at the beginning. And we were very lucky to have some partners who were sharing our vision of QA and were very motivated to collaborate with us. Chicago Northwestern was one of them, PSI from Switzerland, and then Willis Knighton in Louisiana. So together we really scratched our head and came with a design that basically allowed to do all of these things at once. So we have some wedges to measure the energy. We have integrated PPC05 for the output. We have a beam versus X-ray fiducial. I'm not going to go too much into the detail. If you have questions, or both, it's right there at the top of the stairs. 3 weeks ago, we released it at the Estro, so it is now available. It works together with the links, and it's really customizable. You can customize, You can customize the block, the energy you want to measure, and you can mostly customize the input beam. So not only the hardware is important, today we're working more and more on the software integration to make an easy, intuitive, and powerful software. So all of this is integrated into MyQA, where you can customize following your needs exactly what you want to measure. So this is your input beam, for instance. And in a very intuitive way, all you need to do is to select region of interest, and then you say, okay, in this case, I have an energy, I'm expecting this value, this morning, this error. And you do similar region of interest for all of your beam. When you're done doing that, you just save it, and you can schedule it so the test will appear automatically. You allow some user to do it, some other user not to do it. And in the morning, all they need to do is to basically follow what has been scheduled for the day. They run the test. Every information is consolidated in a very visual way. So an important thing we also noticed today is that many customers, they are taking those measurements, they are saving them, sometimes even just printing them, but they don't always look at the consolidated data. So we really wanted to bring an easy way to have the global picture on your data. And that's why we brought what we call the MyQA cockpit, which is basically a database that is shared on all of your computer in the same server, where you can really see how the data is evolving. Last but not least, we also a lot of feedback from PT sites who are telling us, okay, it's great, I'm measuring this every day, and from one day to another, for instance, I have my energy who is changing from 0.1 millimeter. What does that mean? Is it good? Is it not good? Or am I versus the other center? For that reason, we decided to implement what we call the MyQA Cloud, which is a benchmarking tool that allows, if you want to anonymously share your data with user having the same configuration as you. So you can compare many values, such as your variance, average value, with your customers. You have access to trend analysis. You have access to distribution and things like that. So to conclude, we came up with a solution for daily QA, and we want to apply similar things to other aspects of QA. Patient QA, there is a lot of improvements still need to be done. Same on monthly QA and yearly QA, by always focusing on automation, more integration, and more efficiency. Thank you.